Okay, what we're looking at now is how to divide with powers. So this is what we call the second index law. Okay, so we're going to look at firstly what the law is and how to, we're going to show how to come up with it, and then we'll come up with a nice shortcut. Okay, so the second index law, as you can see in the title, is about division. Okay, so a to the power of m divided by a to the n. And you guys should know by now we don't actually use the division sign. We usually make this into a fraction. It's just that that's a little difficult to do when I'm typing. Okay, so the second index law. So if we have, for example, x to the power of 5 divided by x to the power of 3. So this is division. Okay, we're going to look at how we can calculate this, okay, how we can simplify it. All right, so what I want you to do is think about what this actually means. X to the power of 5 means that we have x multiplied by itself 5 times. So that's 3, 4, 5. Okay. And x cubed, or x to the power of 3, is x multiplied by itself 3 times. Okay. Now what we know with this is if you have, for example, x divided by x. Okay. What is x divided by x? It's 1. Okay, so what we can do is we can cancel these two out and replace them with 1s. All right, we have another x divided by x here, and we can replace those with 1s. And we have another x divided by x here, which we can also replace with 1s. So what we get left behind with here is just x times x, which is equal to x squared. Okay, let's have another look. What if we did a to the power of 7, no, let's make it 6 because I don't really want to do this 7 times, divided by a squared. Well, in that case, we're going to have a 6 times, 1, 2, 3, 4, 5, 6. There's multipliers in between them all. Okay, and a squared, which is just a times a. All right, and again, we can now just cancel them in pairs, okay? They have to be cancelled in pairs. You can't just take them all and cancel them out, okay? And remember, really, we're actually replacing those a's with 1 because a divided by a is equal to 1, okay? So just keep that in mind. People seem to think we replace them with zeros, but if we did that, we would end up with 0 for everything, okay? So what we have left is a to the power of 4. All right, so hopefully you can also see another pattern happening here, okay? Because if you look at this first example, x to the power of 5 divided by x to the power of 3 gave us x squared, or x to the power of 2. If you do 5 minus 3, you get 2. Okay, a to the power of 6 divided by a to the power of 2 equals a to the power of 4, and 4 is 6 minus 2. Okay, so our general rule here is a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Okay, and this is our next index law. Okay, so this is index law number 2. Now guys, you might also notice your book uses the word exponent. That's also fine. Okay, exponent is perfectly okay. We call them an index or an exponent. That's absolutely fine, or a power. Okay, it's good that you guys are getting used to learning all the terms. All right, so let's just do an example with some numbers in it, because as we said before, you're also going to have things where there's a coefficient. Okay, and we need to get used to those as well. So let's say that we have 35 m to the power of 6 divided by minus 28 m to the power of 3. Okay, so as with before, the first thing you always need to do is look at those coefficients. So what we're going to do is we're going to use that simplifying strategy that we already used in the previous topic, Okay, so we're going to write 35 and 28, we're going to factorize them. We're going to write it as something times something. Okay, so 35 and 28, you should be able to see the number they have in common, and that number is 7. So we're going to write 35 as 7 times 5. Okay, and minus 28 is going to be minus 7 times 4. Okay, and then we have, this is all going to be multiplied by m to the power of, and now this is where we use our index law here. So it was m, sorry, we've used m's again, so that may be a little confusing, but now we have to subtract the powers. So it's going to be 6 minus 3. Okay, now you should be able to see here that these 7's here can magically cancel out. Just be careful not to cancel out the negative. Okay, that negative is important. So what we're going to get here is minus 5 over 4 m to the power of 6 minus 3, which is 3. Okay, and that's it. All right, you can write it this way. You can write it as minus 5m cubed over 4. This is also fine. Or you can write it as minus 1 1/4 m cubed. Okay, I prefer the first way. Okay. Alright, but it doesn't really matter as long as you know what you're doing with it. I do find a lot of you tend to go straight to this one here. Okay, a lot of you think, oh, it needs to be simplified, it needs to be a mixed number. But actually, these are more difficult to work with when you need to use them in a future part of a question. So I really prefer that you don't convert them to 1 1/4. Okay, unless you're at the very end of a question. If you're using this throughout something, please don't convert them. To be honest, there usually is no need to. The only time you should need to is if we're asking you for in a story situation. Okay, otherwise you really shouldn't be doing it. Okay, so that's one example. Now, one other example I do want to do with you, because it confuses people sometimes, is something like a to the power of 2 divided by 16a to the power of 5. Okay, so again, we need to get those coefficients sorted out first, so we're going to put that out the front. So we have 8 over 16. Okay, then we have our variable a to the power of. Now you need to do 2 minus 5 here. Please be careful with this, because some of you will go, oh, that's a cubed, done. Except it's not a cubed. All right, firstly, 8 over 16 is 1/2. Okay, and then we have a to the power of minus 3. Okay, so you just have to be careful there, because we are doing the top one minus the bottom one. We actually end up with a negative number there, and we will address this in another lesson. Okay, we wouldn't normally leave this like this. We'd actually go another step. However, for now, you guys aren't used to it, so we're going to leave it like this for now. Okay, so when we look at this in a later lesson, you'll see how we can simplify this one more step, but this is enough for the moment. Okay, so good luck.